Let's continue with the pricing of fixed rate bonds. In this class, we discussed the pricing of fixed rate bonds with a fixed risk-adjusted discount rate. So the pricing of an option-free fixed rate bond is carried out with a cash flow model, and to calculate the bond price, the expected cash flow, so consisting of the yearly coupons and the par value at maturity, are discounted back with the expected return. If the bond price determined in this way is paid and the bond is held until maturity, then the expected return used for discounting the cash flows in the valuation model is earned. The expected cash flows of a bond can be either discounted back with a fixed expected return, as we do in this class, and more common is in valuation practice that the expected cash flows of a bond are discounted back with the expected return that correspond to the timing of the cash flows. So if we use now fixed expected risk-adjusted return, then to calculate the bond price, we can take the expected cash flows, which consists of the coupon payments and the par value at maturity, and these expected cash flows are discounted back then with the expected return. So to visualize the calculation, I can draw a timeline, and according to the timeline, we have years or evenly spaced periods. So let's take years. So we are here today on the valuation date, then here in 1 year, in 2 years, and so forth. And then at maturity, we are at point T. And now I can allocate the cash flow pattern. So we have the first coupon is paid at the end of the first year, the second coupon is paid at the end of the second year, and the last coupon together with the par value are paid then at maturity. And now to calculate the bond price today, we have to discount back the expected cash flows with the expected return to obtain then the bond price. And now let's take a closer look at the cash flow model and the impact of the expected return on the bond price. So to explain that, I write down the equation to calculate the bond price. So the bond price, that's the coupon paid at the end of the first period, discounted back with the expected return to the power of 1 year, plus the coupon paid at the end of the second period or the end of the second year that you're discounting back with the expected return over 2 years, plus and so forth, the coupon paid at maturity, plus the par value of the bond that you're discounting back with the expected return then over the time to maturity of the bond. Compared to equity valuation with a cash flow model, we see here that for the price calculation of an option-free fixed-rate bond, the future cash flows do not have to be estimated under uncertainty, but are known. That's obviously not the case in equity valuation, where we have to estimate then the future expected cash flows under uncertainty. Now we see that the cash flows for an option-free fixed-rate bond are constant. That means the bond price can only change due to a change in the expected return. The expected return can be calculated as follows. So to calculate the expected return, we take the risk-free rate and we add to the risk-free rate a risk premium. And now to determine the risk-free rate, we can use either the yield to maturity of a prime government bond. So here we can use the yield to maturity. just abbreviate the yield to maturity then with YTM. Y stands for the yield, T for 2, and M for maturity. So the risk-free rate is either given by the yield to maturity of a prime government bond, that has the same currency and maturity of the risky bond, for which we want to calculate then the bond price, or as a risk-free rate, we can use the swap rate. The swap rate used has the same maturity and is based on the same currency as the risky bond that we want to calculate its price. Now, if we calculate the expected return using the yield to maturity, then the yield to maturity of a risky bond, so I take here for a risky bond a corporate bond, so the yield to maturity of a corporate bond, the yield to maturity, that's the annual expected return if we hold the bond until its maturity. So we have the yield to maturity of the corporate bond that equals then the yield to maturity of a prime government bond with the same maturity and currency as the corporate bond. And then we have to add a risk premium. This risk premium, that's then referred to as the G-spread according to the financial information provider Bloomberg. So that's then the government spread, so the spread that they add to the yield to maturity of a prime government bond to obtain then the yield to maturity of a corporate bond. Now the G-spread, so this risk premium, is affected by the credit risk, so it's affected by credit risk. And the credit risk, that's the risk of loss resulting from the issuer failing to make full and timely payments of the agreed coupon and or the principal, which can lead then to a default in payment or even insolvency of the issuer. Then the level of the G-spread is also affected by market liquidity of the bond. Market liquidity, so therefore affected by the market liquidity risk. The higher the market liquidity risk, the higher then the risk premium, that means the G-spread. The market liquidity risk reflects the liquidity of the bond on the market. A bond has a low market liquidity and therefore high risk if it has a low trading volume, resulting then in a wide bid-ask spread. So then purchases are made at the higher ask price and sales at the lower bid price than in the case of a bond which has enough market liquidity. Then a change in the level of interest rates affects the yield to maturity of a prime government bond. So that's then interest rate risk. So interest rate risk, and interest rate risk occurs if the level of interest rates changes. So if you have a change in the level of interest rates. So interest rate risk, that can be explained as follows. If the level of interest rate increases, then the yield to maturity of the prime government bond rises, which results then in an increase of the yield to maturity of the corporate bond. And the yield to maturity can be used then to calculate the bond price in a cash flow model. So we have then a higher expected return, and a higher expected return results then in a lower bond price. So that's then interest rate risk. Then we see that the bond price can also change due to a change in credit risk. So if the credit risk increases, then this leads to a higher G-spread. A higher G-spread results in a higher yield to maturity of the corporate bond. So a higher return expectation leads then to a lower bond price. Similarly, if the market liquidity risk of the bond increases, then this is reflected in a higher G-spread. A higher G-spread results in a higher yield to maturity of the corporate bond, and a higher discount rate results then in a lower bond price. So we see the risk factors of an option-free bond are interest rate risk, credit risk, and market liquidity risk. Now let's take the following example to calculate the G-spread. So what is the G-spread if the yields to maturity of a 10-year corporate bond and a 10-year risk-free government bond are 3% and 2.3% respectively? So to calculate the G-spread, we can take the equation of the yield to maturity of a corporate bond or of a risky bond that equals then the yield to maturity of a government bond. So a prime government bond with the same maturity and currency as the corporate bond plus the G-spread. And now we know in our example that the yield to maturity of the corporate bond is 3%. That equals then the yield to maturity of the prime government bond of 2.3%. And we see that the G-spread, which is the risk premium, is 0.7%. So that's then how we can calculate the G-spread if the yield to maturities of the corporate bond and the prime government bond are given. In the event that no risk-free government bond with the same time to maturity can be found on the market, so let's say, for example, the corporate bond has a time to maturity of 10 years and we don't find in the market a risk-free government bond with the exact same time to maturity of 10 years, then we can take two bonds, with one with a shorter maturity than 10 years and the other bond then with a longer maturity than 10 years. And then we can linearly interpolate the two yield to maturities of these two risk-free government bonds to come up then with a linearly interpolated yield to maturity that we can use then as the risk-free rate to calculate then the yield to maturity of the corporate bond, which is then our discount rate that we use to discount back the expected cash flows of an option-free bond. So the two government bonds with a longer and a shorter maturity can be defined as follows. So the government bond with the longer maturity has a maturity of T2, which is higher than the time to maturity of the corporate bond TT, and which is higher than the time to maturity of the prime government bond T1. So if I visualize that with a timeline, then here we have T2, that's then the longer maturity of the risk-free government bond. TT is then that time to maturity that we have for the corporate bond, and T1, that's then the time to maturity of the risk-free government bond with a shorter maturity. To linearly interpolate, we can take the following equation. So we take the yield to maturity of the government bond with a shorter maturity. Then we take plus the time to maturity of the corporate bond, for which we want to calculate the yield to maturity of the government bond with the same time to maturity as the corporate bond, minus the time to maturity of the government bond with a shorter maturity, divided by the time to maturity of the government bond with a longer maturity, minus the time to maturity of the government bond with the shorter maturity. And that's then multiplied by the difference between the yield to maturity of the government bond with a longer maturity and the yield to maturity of the government bond with a shorter maturity. And now let's discuss where this equation does come from to linearly interpolate the yield to maturity. So I take an XY diagram. So on the vertical axis we have the dependent variable y, and on the x-axis we have the independent variable x. Then I include two xy points in this diagram. So let's take the first xy point. So I take here x1, and here we have then, for example, y1. That gives then the first xy point in this diagram. And then I take a second xy point. So let's take, for example, here x2. And let's assume we have here then y2. And again, we can combine these 2 points to get then the point x2, y2 in the diagram. Then next we can combine these 2 points with a straight line. In doing so, we will get then here a straight line that goes through these 2 xy points. Now I can include a third xy point in the diagram. So let's take here a point x, which is, let's say it's here, and this point x lies also on the straight line, and we get then on the vertical axis the point y. And now we can determine the slope of this straight line. So to calculate the slope of this straight line, the slope is given as the change in y divided by the change in x. So to calculate the slope, we can take the change in y divided by the change in x. So the change in y, that's given by y2 minus y1. While the change in x is given by x2 minus x1. Then it doesn't matter at which point we calculate the slope of a straight line. The slope of the straight line is always the same along a straight line. So I can calculate now the same slope of the straight line at this point here. So this slope is again the change in y divided by the change in x. The change in y is given by y minus y1, while the change in x is given by x minus x1. And now it doesn't matter where we calculate the slope of a straight line, it's always the same. So we can set the two slopes equal. So we take then y minus y1 divided by x minus x1, that equals then y2 minus y1 divided by x2 minus x1. And now we can take this equation and rearrange this equation according to the dependent variable y. And in doing so, we will get then the following equation. So we have to multiply on both sides of the equal signs x minus x1. And then we have to add on both sides of the equal signs y1. In doing so, we'll get then the following equation. So the dependent variable y equals y1 plus x minus x1 divided by x2 minus x1. That's multiplied by the difference between y2 and y1. And now if you go back to this XY diagram, I can include for the independent variable X the years. So here we have years. And for the dependent variable Y, I can take then the yield. Or if you like, the yield to maturity. And now I can include in this year's yield diagram the yield curve. Let's assume the yield curve looks like this. So that's the yield curve. Then we have on the vertical axis Y2. Y2 is then the yield to maturity of the government bond with the longer time to maturity. And obviously the time to maturity is then T2 for this yield to maturity. And Y1 is then the yield to maturity of the government bond with the shorter time to maturity. So we take here the yield to maturity T1 and the time to maturity is given by T1. And now we know that the corporate bond has a time to maturity which is given in this XY diagram by X. So that's then the time to maturity of the corporate bond that we take now to linearly interpolate the yield to maturities of the two government bonds, one with a longer time to maturity and the other one with a shorter time to maturity. And the linearly interpolated yield to maturity, that's then TT, which reflects then the dependent variable Y. So if I enter now these variables in this equation that we have derived before to linearly interpolate Y, then the yield to maturity for a time to maturity TT, which corresponds to time to maturity of the corporate bond, equals then Y1. Y1, that's the yield to maturity of the government bond with a shorter maturity, plus X. X is the time to maturity of the corporate bond, for which we want to calculate then the linearly interpolated yield to maturity of the government bond. So that's TT. X1 is T1 divided then by X2, that's then T2 minus T1, and that's multiplied then by Y2. Y2 is the yield to maturity of the government bond with the longer maturity, minus the yield to maturity of the government bond with the shorter maturity. So that's the equation that we can use to linearly interpolate then the yield to maturity using two government bonds, one with a longer maturity and the other with a shorter maturity. Let's apply now this equation with the following example. The yields to maturity of 9-year and 11-year risk-free government bonds are 2% and 2.6% respectively. What is now the linearly interpolated yield to maturity for the 10-year risk-free government bond? So we can now apply the equation that we have discussed before. So to calculate the yield to maturity of the government bond with a maturity of 10 years, we can take the yield to maturity of the government bond with a shorter maturity, so that's 2%, plus the time to maturity of the government bond that we want to calculate its yield to maturity, so that's 10 years, minus the time to maturity of the government bond with a shorter maturity, that's 9 years, and that we divide then by the time to maturity of the government bond with a longer maturity, so 11 years minus the time to maturity of the government bond with a shorter maturity of 9 years. And then we multiply that by the difference between the yield to maturity of the government bond with a longer maturity, so 2.6%, and the yield to maturity of the government bond with a shorter maturity of 2%. If you're entering the figures in your calculator, you should obtain then for the interpolated yield to maturity 2.3%. Let's calculate now the price of the Mercedes-Benz Group bond. So the following information is given for this bond maturing on the 27th of February 2031. So the issuer is the Mercedes-Benz Group. Then we see the international securities identification number of the bond. The type of the bond is a corporate bond. Currency is euro. The denomination is 1,000 euros for one bond. And the issue volume amounts to 750 million euros. The issue date is the 27th of February 2019. Then the day count convention is given to calculate the accrued interest. That's actual ICMA. So we take the actual days in a month divided by the actual days that we have in a year. So either 365 days or for a leap year 366 days. And the ICMA stands then for the International Capital Market Association, which is located in Zurich. The coupon is 2% fixed and paid annually. The interest rate is paid every year on the 27th of February, and the maturity date is the 27th of February 2031. The rating is A3, so according to Moody's as at 13th of December 2019. Then the following information is available for the 27th of February 2021. So here the interpolated yield to maturity of bonds from the Federal Republic of Germany with the same time to maturity as the Mercedes-Benz Group bond is given. So that's minus 0.252%. G-spread is 97.2 basis points. And now we have to calculate the price of the Mercedes-Benz Group bond on the coupon date of the 27th of February 2021. Well, let's first calculate the yield to maturity of the Mercedes-Benz Group bond. The yield to maturity can be calculated as follows. So the yield to maturity of the Mercedes-Benz Group bond that can be calculated taking the yield to maturity of the bond from the Federal Republic of Germany, which is minus 0.252%, plus the G-spread, and the G-spread, that's 97.2 basis points, so written in percentages, 0.972%. And if you're entering the figures in your calculator, you should obtain then for the yield to maturity of the Mercedes-Benz Group bond 0.720%. The time to maturity of the Mercedes-Benz Group bond is 10 years. So to calculate the price of the Mercedes-Benz Group bond, we have to use the cash flow model. So the first coupon is paid at the end of the next year. So that's the 27th of February 2022. And the coupon is 2%. That we're discounting back with the yield to maturity of 0.72% over 1 year. Then we take the next coupon, which is 2% and which will be paid then in 2 years, and we are discounting it back with 0.72% over 2 years, and so forth. And the last cash flow consists of the coupon of 2% plus the par value of 100% paid at maturity, so paid on the 27th of February 2031. And these cash flows are discounted back with the yield to maturity of 0.72% over 10 years. If you are entering the figures in your calculator, you should obtain then for the bond price of the Mercedes-Benz Group 112.307%. To calculate the yield to maturity of a corporate bond, we can use as an approximation of the risk-free rate the swap rate instead of the yield to maturity of a prime government bond. And then we have to add a risk premium, and the risk premium that's then referred to as the I spread or interpolated spread, and that's then the name of this risk premium according to the financial information provider Bloomberg. The swap rate taken is then the average swap rate. That's the average of bid and ask swap rates with the same time to maturity and currency as the corporate bond. So to illustrate now the difference between the I spread and the G spread, which both can be used to calculate the yield to maturity of the corporate bond, I can just take the following diagram. So on the vertical axis we have the interest rate, and on the x-axis then the years. So here we have interest rate, and on the x-axis then the years. Let's assume that the corporate bond has a maturity of 10 years. Then to calculate the yield to maturity of the corporate bond using the yield to maturity of a prime government bond, we take the yield to maturity of this prime government bond with a time to maturity of 10 years. And same currency as the corporate bond. And then we add to this yield to maturity of government bond the G spread, which is a return compensation for credit risk and market liquidity risk, to obtain then the yield to maturity of the corporate bond. So this risk premium, that's referred to as the G spread. According to Bloomberg. Then we can calculate the same yield to maturity of the corporate bond, but now we take as an approximation of the risk-free rate the 10-year swap rate. So we take the 10-year swap rate as an approximation of the risk-free rate. And then we have to add a risk premium to obtain then the yield to maturity of the corporate bond. And this risk premium, that's referred to as the DI spread. So we can calculate the yield to maturity of a corporate bond either using as a risk-free rate the yield to maturity of a government bond or the swap rate. In the event that no swap rate with the same time to maturity as the corporate bond can be found on the market, two swap rates with a longer and shorter maturity than the corporate bond are interpolated linearly. Same as we've already discussed with the yield to maturity of the government bond. Then the I spread can be positive or negative. This depends on whether the credit and market liquidity risk of the bond is higher or lower than that of the swap rate determined with the interest rates of the interbank market or the floating side of the interest rate swap. So that means if you take an interest rate swap, with an interest rate swap, the swap rate, which is a fixed rate, is exchanged against the floating rates, and the swap rate is determined then taking the floating side of the interest swap.